In this video, we're going to show that the limit of this surface as x and y heads towards 1, 1, we're going to show that the limit does not exist. So that's our aim, to show that it does not exist. So dead on this point here, the whole surface breaks down. So I hope you can see that there's a gap in between here. So if you punch this surface into a 3D graphical calculator, it will then give you this. I've rotated it in such a way that that is displaying it in an awkward way. So this is your x-axis, this is your y-axis, this is your z-axis. I've rotated it in this weird awkward angle to show you that there's a gap. I hope you can see there's a gap in between here, which is at 1, 1. There's a gap in between there. Well, anyway, for us, our normal routine to show the limit here is to consider along x equals 1. So along this x equals 1 here, you're going to have a plane, a vertical plane. So along this plane, so along x equals 1, along x equals 1, we would put 1 into the x. This whole thing here will then become this. So here you can see that there's a difference of 2 squares, easily square rootable, and there happens to be a minus in between. Then you can jump to +1, -1, and then these two, they cancel each other out, and then, well, that would then leave you with y plus 1 as y tends to 1. So you can see that the limit here is 2. So along the plane x equals 1, along this plane, the limit will be 2. So the next thing to do is the next natural thing to do is to consider along this plane where y equals 1. So y equals 1, you would put this into the y, and then you would put the 1 into the y here. So this thing here would hang on. So that thing there. Well, if you put 1 into here and into here, you're going to get 0 over 0. So which to us is meaningless, because we can't determine anything when it's 0 over 0. To us it's meaningless. So this turns out to be useless to us. So now looking at this, the trick and the clever part is to consider along y equals x. So what that means is along here is useless to us. So now let's consider along y equals x, which is the diagonal line along like this. So you can see that clearly it passes through our desired point 1, 1. So this line here does pass through our intended region, our intended point here, 1, 1. So so now consider along this thing here. So hang on. So along y equals x, we would put x into y and x into y here. So this whole thing here will then become this. Will then become this. Will then become this. So now you're supposed to be able to recognize that whenever you have x to the power 3 minus 1, is a special case where you can jump from here to here. You're supposed to be able to recognize that by now. But suppose you didn't know this. y equals x to the power 3 looks like this. And then minus 1, you drag it down by 1. And by inspection, you can see that x minus 1 is, well, you know this is 1, so x minus 1 is a factor. So you know that you can rewrite this thing as something x squared plus something x plus something, because this is a factor, because you know it passes through 1. So you would get this thing here, get this thing divided by something that you know is a factor, and then follow the whole process, which I'm not going to go through, but it does give you this thing here. And I'm expecting you to know that you can rewrite this thing as this. And then now, so rewrite this thing as this. So now notice that these two are exactly the same. So they cancel each other out, giving you this. So along y equals x, the limit as x heads towards 1 is well, it's going to be 3. So the limit is 3. So what we've got here is along y equals x. Hang on. What we've got is this: along y equals x. Along y equals x, the limit is 3, and then along x equals 1, the limit is 2. So if you have two different, well, if they're heading towards different places, then we know that the limit does not exist, because for a limit to exist, no matter which direction you approach 1, 1, it should head to the same elevation. Here, if you approach in this direction, then you're going to head towards a limit of 2. If you head in this direction, you head towards a limit of 3. So they don't match. So therefore, we can conclude that the limit does not exist. Okay.